Hey everybody, it's time for lesson 7 of chapter 1, and we are going to be talking about something called function notation, and we're going to be evaluating functions. Now, we've used the word evaluate before. So, like for example, if I say evaluate 3xy for x equals 4 and y equals -2, that would mean I would have 3 times 4 times -2. 3 times 4 is 12, times -2 is -24. Now, let's say I have this. Evaluate y equals 3x minus 2 for x equals 5. Now, this looks like a line, right? The equation of a line, y equals mx plus b. So what I'm really asking is, what does y equal? What does y equal if x equals 5? Well, I'm going to plug it in. So I have y equals 3 times 5 minus 2. And 3 times 5 minus 2 is 13. Okay? Now, instead of writing y equals, I'm going to introduce you to a new way of writing something, which we call function notation. Function notation. And anytime you see the word notation, it just means a new way of writing something. Okay? Function notation looks like this. It's f and then an x right after it in parentheses. And we read this as f of x. F of x. Okay? F of x. And f of x in any situation can replace y. They are the same thing. Okay? So let's consider this same example up here. Instead of writing y equals 3x minus 2, I'm going to write f of x equals 3x minus 2. Okay? These two things are the same. Now you might be thinking, what's the point of this? Okay, this is just an easier way of representing the information. So for example, I might say find f of 5. Okay, if I say find f of 5, well, 5 has replaced what? It's replaced x. That means everywhere in this equation, I'm going to change an x to 5. And just like we found before, we get 13. So when I write f of 5 equals 13, that tells me actually a lot of information. That tells me that when x is 5, I get 13 out of the function. So remember, functions are like a machine, right? We put numbers in, we get numbers out. And this is saying that if I put 5 into the machine, I'm going to get 13 out. Let's try some more examples. Example 1. Let's say I have f of x equals 7 minus 2x. Okay. Find f of 0. Well, f of 0 means that x is 0. So I have 7 minus 2 times 0. Well, follow PEMDAS. 2 times 0 is 0, and 7 minus 0 is 7. Let's do f of -2. Well, now I'm going to put -2 in for x. -2 times -2 is 4, so I have 7 plus 4, which gives me 11. Let's do another one. F of 1/2. Ooh, can we do that? Yeah, of course we can. I'm going to, just like the other ones, put 1/2 in the place of x. Now what's 2 times 1/2? 2 times 1/2 is just 1. So I have 7 minus 1, which gives me 6. All right, let's try another example. Let's say I have f of x, a new function here, x squared minus 4x. We're going to do a couple examples again. F of 1. So again, this means that I'm going to put 1 in the place of x. But look at this equation. X shows up in 2 places. But guess what that means? Both x's are going to become 1. So instead of x squared, I now have 1 squared. Instead of 4x, I have 4 times 1. Now let's follow PEMDAS. 1 squared is 1. 4 times 1 is 4. And 1 minus 4 is negative 3. Let's try this. F of negative 3. So again, same thing. X squared minus 4x. Both x's are going to become negative 3. Negative 3 squared is positive 9. Negative 4 times negative 3 is positive 12. And 9 plus 12 gives me 21. All right. Flip the page, please. Well, unless you don't need to. I'm flipping the page. You might have more room on your page. So, example 2. Okay. Graph each function. Okay. Let's say I have this. I'm going to do a mapping diagram here. 3, 5, 7, 9. And the second one, 2, 6, and 10. 3 goes to 2, 5 goes to 6, 7 goes to 10, and 9 goes to 10. Okay, so I'm going to make a graph here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got to make sure my y values go all the way up to 10. And my x values have to go all the way to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3, 2. 3, 2. Boom. 5, 6. 1, 2, 3, 4, 5, 6. 7, 10. 7, 10, and 9, 10. Now, we are not going to connect the points. Do not connect points. Because we have only been given these individual points. Okay? Now, let's look at this one. F of x equals 2x plus 1. That looks familiar, right? Slope-intercept form. Because f of x is the same thing as y. So if you want to think of it as y equals 2x plus 1, you certainly can. So that means I'm going to make my graph here. That's the part that takes the longest. Okay. I begin at 1, and I go up 2 over 1. Up 2 over 1. I'm going to put a couple points this way. Now, let me ask you something. Can I connect the points here? The answer is yes. This is different than the first example because I can put in any number for x. I could say x is 0.5. I could say it's 1.2. I could say it's negative pi. Okay, we can have all of the numbers in between these x values, the integer x values. So we can actually connect these points. All right, that is it for the notes on lesson 7. Make sure you check Google Classroom to see what you need to do in the book.